Let's look at an example of stoichiometry, this time how energy can be incorporated into stoichiometry. So the question we have to answer is, if I were to combine methane and then some other material, I will produce carbon dioxide, water, and energy. Do you know what that unknown material is? That's correct. It's going to be oxygen. Now that we have the word equation, we can write a balanced chemical equation. Methane, you might be familiar with, is called natural gas. It has the formula CH4. Now, we're given some other additional information here that 1 mole of oxygen produces 350 kilojoules of energy for this equation. So I'm going to write down my formulas. Methane is CH4. Oxygen is O2. You have to recall oxygen is diatomic. Don't just write O. Carbon dioxide is CO2, water H2O, and then we're going to get our energy. Remember, it says we get 1 mole of oxygen, 350 kilojoules. So as the equation is written right now, we have 1 mole of methane, we'll get 350 kilojoules of energy. Next, we need to balance the chemical equation. The carbons, I notice there's 1 carbon on both sides of the equation. However, when I look at oxygens, on the product side, I have 2 oxygens and another one, that's 3. That's an odd number, and I have an even number 2 on the reactant side. For this reason, to make it work, I must at minimum put a coefficient of 2 in front of the water so that I now have 4 oxygens, 2 oxygens here, plus another 2 here, 4 oxygens on the product side, and now I will need to add a coefficient 2 in front of the oxygen on the reactant side. As I continue to look around, I now have 4 hydrogens and 4 hydrogens, so I now have a balanced equation. But notice that because it was 1 mole of oxygen was 350 kilojoules, now we have 2 moles of oxygen, 700 kilojoules. So the question will be, if I begin with 100 grams of methane and 100 grams of oxygen, how much energy would I expect to generate? Now, because we're given quantities of 2 different reactants, this is a limiting reactant problem. As we've done before, we must convert each of these into moles. So I'm going to divide the molar mass of methane, that's 16 grams per mole, the 100 divided by 16 grams per mole, and that means I have 6.25 moles of methane. Oxygen weighs 32 grams per mole. That's O is 16 for oxygen. There's 2 of them, so 32 grams per mole. So 100 divided by 32 means I have 3.125 moles of oxygen. Now, at this point, I need to pay attention to the coefficient. Notice the equation says for every 1 mole of methane, I need 2 moles of oxygen. In other words, double the amount of oxygen. Now I have less than that. I could divide the 6.25 by its coefficient 1, and I'll get 6.25. I'll do the same thing with the oxygen. Oxygen has a coefficient 2, so considering that, I'll take my 3.125 moles of oxygen, divide by 2, and get the number 1.56. Now, looking at these 2 numbers, the smaller of the 2 numbers, right here, is going to be the limiting reactant. So therefore, oxygen in this case is limiting, and methane is excess. Now, of all the numbers that I've put here and worked on, there's only one important number to me, and that number is right here, the 3.125 moles of oxygen. The moles of limiting reactant will determine everything in this problem. So I'm going to clean things up, get rid of this, and we'll just fully get rid of it and move the 3.125 moles back to the problem. Now, if this was our original problem stating we had 3.125 moles of oxygen, and we'd like to know how many kilojoules this would be, we'll set it up like all the other problems we've done in the past. What are we looking for? X kilojoules equal to what do we know? 3.125 moles of oxygen. My first step will be to use the coefficients from the balanced chemical equation. Notice it says 2 moles of oxygen produces 700 kilojoules. I could put that in, or I could just as easily use 1 mole of oxygen, 350 kilojoules. I'll put the 2 moles of oxygen on the bottom so that moles of oxygen up here and moles of oxygen down here will cancel, and 700 kilojoules here. Notice the moles of oxygen cancel, and I'm left with my answer, 1094 kilojoules.